Now let's do some partial fraction resolution using identities. So we have this fraction and we have to resolve it into its partial fractions. Now you can see that the variable in the denominator has a power. So x has a power of 3. So we'll use the type 3 uh, resolution method. Now over here you'll actually have to factorize this cubic expression into its quadratic and linear expressions. Now you can do that by referring to the lectures in chapter 4 where I've explained how to do this. And once you've done that, you'll basically do what you've done before. Now the linear factor will have one partial fraction, which is this, and the quadratic factor will have one partial fraction, which is this. And so now you'll just do what you've done before. You'll take the LCM so that the denominators on the left hand side and the right hand side are equal. So a will be multiplied with this quadratic factor and bx plus c will be multiplied with this linear factor, and so will the denominators. So now you have this expression. The denominators is now equal, so they will be cancelled out, and so you'll equate the numerators equal to each other. And after doing the calculations, you get this equation, which is equation number 3. Now when you plug in x is equal to -1 in equation number 2, what happens? Well, as you can see, this is equation number 2. When you plug in x is equal to -1, this linear expression becomes 0, 1 minus 1. And since this 0 will be multiplied with bx plus c, this also becomes 0. So this entire expression over here becomes 0. And so you're left with this and this. And when you plug in x is equal to 1 into every x over here, this is what you'll get. This expression, this equation. And so 3a is equal to 2 and a is equal to 2 by 3. So we have found the value of a. Now we'll equate the coefficients of x squared and x on the left hand side and the right hand side in equation number 3. What was equation number 3? This was equation number 3. Now when you actually simplify this, you can see that a plus b is the coefficient of x squared and minus a plus b plus c is the coefficient of x, and at the end you're left with plus a and plus c as the final constants. Now on the left hand side, the coefficient of x squared is 1 and there is no expression for x, so the coefficient of x is 0 and you have this 1. So a plus b is equal to 1, since a plus b is the coefficient of x squared on the right hand side and 1 is the coefficient of x squared on the left hand side. So when you equate a plus b is equal to 1, and since you've already found the value of a over here and you plug that in, you find out that the value of b is equal to 1 by 3. Now to find the value of x, as you remember, in equation number 3, the coefficient of x is minus a plus b plus c. And on the left hand side, you see that there is no expression for x. So the coefficient of x on the left hand side is 0. Now we found the values of a and b. So when you plug those in, you find out that the value of c is equal to 1 by 3. And when you plug a, b, and c into equation number 1, you find out that this is what you get. Now, when you bring this 3 to the denominator, and these 3's will also go into the denominator. So this is the final result. These are the required partial fractions.